So now we are going to see why do we need a starter for an induction motor. So the induction motor needs starter like your DC motor. So we are going to see the reason why we need starting in induction motor. So two problems we have seen in induction motor because of the squirrel cage rotor construction, right? One is the low starting torque and the heavy current when the motor is started. So once the motor is started, heavy current will flow through your motor, so which is going to damage your windings. That problem is there. And another problem is the induction motor, since it is having a squirrel cage rotor, it is going to always have a low starting torque. The starting torque is going to be less. Okay, so this is a drawback in your motor. And the heavy current which is going to flow inside the motor is going to damage your windings. And this heavy current is flowing because we are going to have low resistance. The rotor is going to have very less resistance. You know, when resistance is less, current will be heavy. So when heavy current is going to flow, the reason is going to be the low resistance rotor of the squirrel cage type. So if I am going to ensure that the squirrel cage motor is slightly modified to give a high resistance, then less current will flow and the motor will get a very high starting torque. But if I increase the resistance, naturally the loss will be copper loss will be increasing, so which will lead to excessive heating of the motor and efficiency will be reduced. And the second thing, the speed of variation of load would be quite large. So the motor will not be consistently running in average same speed. So you see, if I need high resistance for starting, but if I'm going to have that high resistance throughout the period the motor is going to run, the two losses, two adverse effects. First one is I'm going to have a very high copper loss, which will lead to heating and reduced efficiency. Second one, the motor will be running at random speed. The speed will not be consistently same. So that is why you cannot start your induction motor directly connected to your power supply. You need a device called starter, just like your DC motors. Okay. And another problem in induction motor is we have seen the difference in induction motor and transformer. The induction motor will have a very large amount of no load current and full load current. So when you compare the transformer, it is 25 to 40% higher no load current is drawn, and 4 to 7 times full load current is drawn excessively. So if it is connected directly to power supply without any resistance, so that is going to be which will induce a very huge amount of EMF in your rotor. So this will short circuit your rotor. So because of large circulating current in the rotor winding, it will behave like the rotor is short circuited. So it will start burning because of the heavy current circulating in the rotor winding. Okay, so this if you are having a uh, this motor along with a series of other equipments, means because of heavy current drawn by this motor, the other equipments will be drawing less amount of current, which will lead to undesirable dimming of lamps in the vicinity. So in case in your house, if you are starting an induction motor directly connecting to your main means, when the motor is starting, the tube lights and all will start dimming up because the motor will consume a larger amount of current. So they say that the induction motor should not be started directly. So we need to have a device which is going to start the motor, and then you can remove the device till the motor is running. Just like how you have a starter for a DC motor, induction motors also cannot be started when you are going to connect them directly to power supply. Okay, so for heavy duty motors, you need to have more resistance in the rotor to prevent less current flow in the rotor, or you have to apply a low voltage at the starting so that the EMF induced is also going to be less. Okay, so the need of starter is very, very clear. A huge amount of current is going to flow into your rotor, which is going to reduce the torque. Okay.